So now we're going to start our review for our final. So I grouped the topics that we've discussed into 4 groups. So the first one is sets, and that was from chapter 1. The second group of topics, we talked about relations and equivalence relations. This was chapter 9. Our third group of topics was functions, where we talked about injective, surjective, composition, and inverses. This was chapter 10. And finally, we talked about mathematical induction, which is chapter 6. So we're going to start with sets. So we're going to start with the definition of a set. A set is a collection of objects the objects themselves that make up a set are called its elements. So let's look at some examples of sets. You could have a set with a finite number of elements. So for example, the integers from 1 through 5. This is a set with 5 elements in it. You could also have a set with an infinite number of elements in it. So for example, 1, 3, 5, 7, 9. Right? This is the set of all positive odd integers. So from here, we also talked about the empty set or the null set. The way we denote it is with a 0 and a slash. It's this unique set containing no elements in it. So then we talked about a variety of commonly referenced sets. So first set was N. This is the set of natural numbers. We had Z, which was the set of integers. Q is the set of rational numbers. R, which is the set of real numbers. And C is the set of complex numbers. And so remember, it's important to pay attention to which set you're working with. So let's look at an example here. Let's say set A is the set of all the x and n where x squared minus 2 equals 0. So here, I'm going to claim that this set A is the empty set. So to see that, we're going to look at this equation over here. X squared minus 2 equals 0 and solve. And so x equals plus or minus the square root of 2. So I get 2 solutions to this equation. I get x equals negative square root of 2 and x equals positive square root of 2. And the problem is that these are not natural numbers. And so that's why the set A is the empty set. Now if I change my set to, let's say, B, if instead I'm looking at x and r, where x squared minus 2 equals 0, now, because I'm working with real numbers, this set is not empty. It contains two elements, and those are negative square root of 2 and square root of 2. So it's important to pay attention to your domain, essentially, or what set your elements belong to. So now let's define a subset. A set A is called a subset of a set B if every element of A also belongs to B. And the notation we use here is A is a subset of B. So think of some examples of subsets. You can come up with your own example, but I have one in particular we're going to look at. So every rational number, remember irrational numbers are ones you can write as fractions, is a real number. So in particular, Q is a subset of R. Every element of Q is also an element of R. So from here we talked about Venn diagrams for sets. So remember, they were a way of visualizing our sets. So we had two different pictures we would look at. So if you're dealing with two sets, so A and B, your diagram would look like, here's set A, here's set B, and then this box represents our universal set. And if you had three sets, your Venn diagram looked a little bit different. It still had a box, but now I have three circles. So A, B, and C. And again, this set U is the universal set. So let's look at an example here where we draw this diagram. So draw the Venn diagram corresponding to our universal set will be A, B, C, D, E, and F. Our set A would be A, C, E, and our set B would be B, C, E, and F. So here I have two sets. So my Venn diagram is the one that has two circles. Here's A, here's B, here's U. So we're going to start with what the intersection of these two sets. So you're looking at for what elements go in this region right here. So what elements go in that region right there? Well, what do they have in common? If I look, both of these sets have the element C in there. So we use a single dot to represent an element, C. And then what other elements do they have in common? They have E in common, and that's it. So there's C, there's E. And now we're going to fill in the rest of the diagram. So the element A is in the set A, but it's not in B. B and F are in B, but not in A. And then if I look at my universal set, I'm missing D. So that's going to belong only to the universal set. So this is a nice way to visualize the sets, and you can see what they have in common, what they don't have in common pretty easily. So we're going to end this video by talking about the power set. So definition. The power set of A is the set consisting of all subsets of A and is denoted P of A. So let's look at an example here. So let's say my set A is going to be the set A, B, C, and D. What would the power set of A be? Well, the empty set is always a subset of any set. And then I have sets with subsets with just one element. So there's A, there's B, there's C, and there's D. Then I have subsets with two elements, AB, AC, AD. I have BC, BD, and then CD. And then with three elements, ABC, ABD, BC, BCD. Oh, and I'm missing ACD. And then finally the set ABCD. So how many sets do I have here? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. And remember, the number of subsets here is 2 to the n, where n is the number of elements, so it's 2 to the 4th, which is 16.